All right, kiddos, welcome to your first real ed puzzle made by yours truly. See if you miss me when you're not at school. Boom, here's a video. No problem. I'm always watching. Anywho, so today we're going to be going over rational numbers as decimals. There is the long version and then there's the short version. I'm going to teach you both, but I recommend just using the short version because it's easier. You may need to know the steps involved in the long version, which is why your notes are centered around that. But at the end of the day, when it comes time to, be quizzed on this, I've told you, if I haven't, I'm going to tell you a million times. I don't care how you get the answer, just get me the right answer. Okay. So in your Schoology, these are the two notes. We have the interactive notebook, and then we have the handwritten notes that I made for you. I have already downloaded them because it's just easier for me to share them. And so we will go over the notes. I break it down basically step by step, and then we'll practice a couple problems. So as far as the handwritten notes are concerned, basically what we're trying to do here is we're trying to write repeating decimals as fractions. It's very hard to work with a repeating decimal because it goes on and on and on forever. So if you're having to work with these numbers, then you make them into into a fraction, and they're a little bit easier to work with. Okay, so there's 5 steps. I'm going to go through the 5, then I'm going to show you what each of those steps look like. And then, like I said, we'll do a couple practice problems. I will warn you now, to do this, you guys need to go ahead and brush up on your simplifying fractions, because some of the answers that you guys get are going to be kind of big. And in the classroom, I hung up those divisibility rules because that will help you with simplifying fractions. Okay, so we're going to run through the steps. You guys all should have this handout so you can kind of go along with me here. The first thing that you're going to do is you need to assign a variable that's going to represent that repeating decimal. It can be any variable that you want. We tend to use X as a variable. Sometimes I don't like using X because it looks exactly like the multiplication sign, but you can basically use any letter that you want to, okay? So once you assign a letter, easy peasy, first step. Then you're going to write out an equation, which basically is just variable equals decimal. So if you look down here, I kind of put step 1 and step 2 together. So we are using X here. And then you're simply, step 2 is just saying that X equals whatever that variable is for, I'm sorry, not the variable, whatever that decimal is. So for us, it's 4.15. So that's it. Step 2, check, done. For step 3, this is where it gets a little bit kind of crazy. Okay, you're going to multiply both sides by 10D. Now D is a variable, okay, and the D here, basically what number you're going to put here is how many digits are repeating. Okay, so for example, when we have 4.15, 15 is repeating over and over. That's 2 digits. So we're going to be using 10 to the second power. Now, 10 to the second power, little note, this number tells you how many zeros. So guess what 10 to the second power is? 100. Guess what 10 to the third power is? 1, 2, 3. Okay, so you guys will have a chance to, play around with that. But basically, just so you guys are aware, that D is how many digits are repeating, not total digits. Because if you're looking at 4.15, that's 3 digits, but that 4 is not repeating. So it's how many digits are repeating. That is what your D is going to be. Okay. Once you do that, sorry, let me erase. It's been a minute since I've had to toggle around on these screens, so you're going to have to be a little patient with me, but I'm doing it. You're going to subtract equivalent expressions of the variable and the repeating decimal from each side of the equation. You're basically now solving for X. And then you need to, like I said, write an equivalent fraction and reduce. Okay. So that does sound super complicated. I feel like when you break it down, it gets less complicated, but don't worry, because there's an even less complicated way of doing it. And I just used, you know, complicated like 7 times. So trust me, I'm a professional. So you can see on the notes here, we assigned X. So that was step 1. We wrote our equation, X equals 4.15 repeating. That was step 2. So step 3, we're figuring out how many digits are repeating. We know the 4 is not, it is just the 1 and the 5. So our D is going to equal 2, which we wrote right here. I wrote right here. And we know 10 to the second is 100. So the first 3 steps, not super challenging. Let's move on and look at step number 4. Sorry, I got this. I'm a professional. Wait, okay. So now we're going to multiply the equation in step 2, which for us was this one here. X equals 4.15 by 10 to the second power, or 100. So you have to do both sides. So you get 100x equals, and then remember, whenever you guys are multiplying, and this is something that you should have learned last year, fingers crossed, maybe not my 7th graders, but for sure my 8th graders should have learned this last year. When you're multiplying a decimal by any of the, oh my gosh, total brain fart, multiples of 100, the number of zeros tells you how many places to move the decimal point. So 100 has 2 zeros. So guess how many places we're moving the decimal? 1, 2. So our new number is 415 point. We still have that 1, 5 that's going to repeat over and over and over again. Okay. So our new equation looks like this: 100x equals 4.15.15 repeating. Okay. If this were, let's say, 1,000, then you would have moved this decimal 1, 2, 3 places. You would have had 4, 1, 5, 1 decimal 5, 1 repeating. So those zeros in your multiples of 10 tell you how many places you're going to be moving that decimal point. And because they are positive numbers, we are moving the decimal place to the right. Okay. So we have our new equation. Let me clean the screen up a little bit, and then we will move on to the next step, where we are going to subtract the original equation from the one that we just made. So, oops, sorry, I need my mousy mouse, not my pen. Okay. So we have the equation that we just made here, right? Here's our equation from step 2. And we're simply subtracting. What is 100x minus x? 99x. What is 415.15 repeating minus 4.15 repeating? It is 411. Even, no decimals anymore. All right. So now we have 99x equals 411. We are solving for x. You need to do the opposite. So because we are multiplying 99 times x, we need to divide. The opposite of multiplication is division. So we are dividing by 99 on both sides. And you should end with this right here. X equals 411 over 99. Now, you need to know whether or not these fractions can be reduced. Because if you don't know and you leave this answer, 411 over 99, you're going to get the answer wrong. So you have to use those divisibility rules. They are up in the classroom. I will make sure all of you have a set in your journals, okay? But you have to use those divisibility rules. Otherwise, you're going to sit there and try to divide 411 by everything. So our rule for divisibility by 3 says if you add all the digits and that answer is divisible by 3, the whole number is. So 4 plus 1 is 6. Therefore, 411 is divisible by 3. 9 plus 9 is 18. 18 is divisible by 3. So 99 is also divisible by 3. You reduce that fraction, and the answer that you're going to end up with, your final answer for this whole problem, is x is 137 over 33. So therefore, the decimal 4.15 repeating in fraction form is 137 over 33. And I know that it seems complicated. Like I said, there is a shortcut, but I want you guys to know these steps and know how to get this fraction answer. Okay? You may have to fill in the blanks on those test questions. You know, maybe they give you steps 1 through 4 and you have to complete step 5. Maybe they give you 1, 2, and 3 and you have to figure out what step 4 is. So know the steps, but for right now, when it comes to your mid-chapter checkpoint, I just need you to be able to tell me this right here. I don't necessarily care how you get there. Okay? So I'm going to pause for a minute and I will be right back with some more. I know, you're welcome. All right, so now we are looking at our interactive notebook. We're going to be going through the blanks and then working on some examples. We are going to write our fractions as decimals. We are going to practice writing decimals as fractions. And then here's the big one where we are going to write a repeating decimal as a fraction. And there's that word, or those words, simplest form. Okay. So first things first, this is coming from our lesson Monday and Wednesday-ish. We have a rational number, and we know that a rational number is a number that can be written as a blank, where A and B are blank and B cannot equal 0. So this is exactly the same wording that we already used in our notes. I'm going to give you guys a second to answer that Edpuzzle question, and then I will reveal the answer. Now you have to bear with me. The writing on this can sometimes be a little we're going to keep it pink. So we know that a rational number is a number that can be written as a fraction. I know, don't judge. Okay, I'm also a lefty and they did not set this up for left-handed people. A and B are integers. And we know that our numerator shouldn't be 0 either. Denominator cannot be 0. A blank decimal is a decimal that ends. That one there is terminating. That is a very fancy way of saying it ends. Terminating. Okay. A blank decimal is a decimal that has a repeating pattern and does not end. Go ahead and take a second and puzzle that. So the answer there is repeating. Oops, repeating. A repeating. Okay, so obviously I'm going to have to work on the handwriting here. A repeating decimal has a repeating pattern. It does not end. A blank written above the repeating decimal indicates that a pattern repeats forever. It is a line, and only the part above it is what repeats. So sometimes you might have, let's say, 2.37777. That would be written as 2.37 repeating. The 3 does not repeat, just that 7. Okay. In order to write a fraction as a decimal, you need to do what? What math needs to be done? Divide. You must divide the numerator by the denominator. And I do have a way to help you. And that's what we're actually going to practice right now. So let me clear this off. Hopefully you wrote all those down on your notey notes. There's got to be a faster way to clear this, right? Yeah, look at me learning stuff. All right, let's scroll up a little bit. Okay, so we are going to be writing these fractions as decimals. I'm going to do the first one. You guys are going to do the second one on your own, okay? So it tells us here that we are dividing okay, the numerator, top number, by the denominator, bottom number. So all you have to do is throw him into the box. Now we know that there is nothing that we can multiply 20 by that's going to get us 6. So this is where you add a decimal on top, and then you can add a 0. 6.0 is still 6, right? We didn't change the value. We just made it a number that we can now work with. So what can we multiply 20 by in order to get 60? Hopefully, you guys said 3. 3 times 20 is 20. I'm sorry. 3 times 20 is 60. 60 minus 60 is 0. So 6 over 20 as a decimal is decimal 3, or 3/10. Okay. I want you guys to try -2 and 1 over 11th on your own. Go ahead and put your answer in the Edpuzzle, and then we'll solve it together. All right, so I'm going to go ahead and we're going to zoom in a little bit here so I have more room to work. Okay. The first thing that I would suggest is just get rid of that whole number. You should know, you should have learned, I'll say, but now we're going to know, if we didn't before, that a whole number goes on the left side of the decimal. So boom, there's half the battle right there. Now we just need to worry about the fraction. So once again, we're going to throw that 1 into the box. There's nothing that we can multiply 11 by that's going to get us 1. So we're going to add the decimal up here, add a 0. What can we multiply 11 by that will give us 10? Still nothing. So put a 0 here. And now we're going to add another 0 down here. Now we're getting somewhere. What can we multiply 11 by that's going to get us close to 100 without going over? Hopefully you said 9. 9 times 11 is 99. You solve this same as regular. 100 minus 99 is 1. And then you start the whole process again. We are going to leave it. No, let's do the process one more time. So what times 11 will give you 1? Oh my gosh, I totally messed that up. Okay. Edit, edit, edit. So now we start the process again. We need to add the 0 here, add a 0 here. 11 times what will get us close to 10 without going over? Nothing. So we add another 0, bring our line over. Now we have 100 again, and this should look super familiar because we just did this. You know it's going to be 9. That's going to give you 99. And you should be able to see here now that this is going to repeat over and over again. Not just the 9 though, 0, 9 repeats. So what is -2 and 1/11? It's going to be -2 decimal 9/100ths repeating. So it's going to be 090909 until infinity. To infinity and beyond. All right. Almost done. I know it seems like a lot, but I promise it's not. And that's why you get to keep your notes. To write a terminating decimal as a fraction, we're going to say the decimal using place value. Using place value, because that's going to tell us what our denominator is going to be. So we're going to write it super nice. Yes, feel it. I feel this one's going to be good. Boom. All right, maybe the E. Then we're going to write the fraction and there's that word again. Simplify if necessary. So let's practice. This decimal is 28 hundredths because the 8 is in the hundredths place. So to write it as a fraction, it would be 28 over 100. Now, right away, both these numbers are even. So go ahead in Edpuzzle and tell me what is 28 hundredths or 28 over 100 simplified. Okay, just in case you need a refresher, 28, I like to use the tree, makes my life easier. So what times what gives us 28? Since it's even, I always start with 2. So 2 times what gives us 28? 14. This is prime, so I circle it. 14, 7, and 2, both prime, so I circle it. How do we make 28? 7 times 2 times 2. Boop. I'm going to erase this, and we're going to do the same thing with 100, except this time I'm going to use, 4 and 25. Neither are prime. 4 is 2 and 2. Those are prime. 25 is 5 and 5. Those are prime. So we have 2 times 2 times 5 times 5. My favorite part of simplifying, if it's on the top and the bottom, cross it out. We have 1, 2 here, 1, 2 here, 1, 2 here, 1, 2 here. So what we have left is a 7 on top and 5 times 5 on the bottom. So the answer is 7/25 or 7 over 25. Now I want you to do this one on your own. Put your answer in Edpuzzle, and then we will do it together. So this one is 5 thousandths. So it's going to have a 5 in the numerator, 1,000 on the bottom. This one should be easy to simplify because both of them are able to be divided by 5. 5 divided by 5 is 1. 1,000 divided by 5 is 200. So that would be 1 over 200. And then the last part, to write a repeating decimal as a fraction. Here we go. We have an equation where x equals the repeating, make it say repeating decimal. So x equals 0.7 repeating. That was step 1 and step 2. We just did it. Now we're going to multiply by a power of 10. How many repeating decimals, I'm sorry, how many repeating digits do we have here? Only 1. So it's going to be 10 to the first power, which is 10. So you have x times, see, that's why I don't like using x. Hold, please. We're going to do it this way. We have x times 10, which is 10x. And then we have 10 times repeating 7. It is a positive, so we're moving the decimal 1 to the right. So you're going to get 7 and 7 repeating. Now we need to go ahead and subtract our original equation from this one. Okay, so we're going to subtract. So minus x minus 0.7 repeating. So we're going to have 9x equals 7. And then divide off of that x. So x equals 7, 9. And that is this form. And we are done. So it sounds a lot harder than it is, I promise. When I see you in small group, we're going to go over the shortcut. But you know, you should be able to do this. It's a whole lot of prior knowledge though, and that's where you might need to pause and rewatch, or maybe look up a video on simplifying fractions or solving for x. But I know you can do it, and we'll be reinforcing it in small group. So once you are finished with this Edpuzzle, you can go ahead and start working on your classwork. Okay, bye.